Okay. So question is, we are starting.
Assalamu alaikum, sir.
Walaikum assalam. If we consider part C of the question, because they are asking about the half-life, and previous part is describe apparatus and procedure of beta. We will discuss that part later, because first of all, we need to study about half-life. So in the first part, state what is meant by half-life of thorium-229. So you just need to write down the definition. Okay. We already discussed the definition of half-life, right? So there are two definitions: the time taken for a radioactive sample to degrees to its radioactive nuclei, or second one is time taken for the radioactive element to decrease its activity to the half of its initial value. Okay. So you just need to write any one definition. Okay. Next part is a sample of pure thorium-229 contains this much of atoms, 4 exponent 14 atoms. So this is the number of atom given in the sample of thorium-229. Then after 22,000 years, the number of atom in the sample is this, 5 exponent 13. Determine the half-life of thorium-229. Show your working. Okay. So basically, this is initial value, right? And this is what we say the targeted value, right? Because according to the question, this is your targeted value. Okay. In your question, when you like get this type of value, when you got two different values, we know that first one is the initial value. We have to start from there. And the next one is random value. You don't know about it. Either it is half-life, second half-life, third life half-life. So you don't know about the second value. Okay. So this is our main target actually. And we know that after 22,000 years, okay, so you need to perform simple process. First of all, consider initial value. Your initial value is 4 into 10 to the power 14. For example, if we perform first half-life, right? Because your main focus is to find out half-life. The question is determine the half-life. So just ignore the targeted value for the time being. We will get that value also. First of all, try to figure out that after first half-life, what will be the value of the sample remains after first half-life. So 4 exponent 14 divided by,
Divide by 2.
yes. So it will be 2 exponent 14, right? And this is the first half-life, right? T half. Okay. So after first half-life, you got the value 2 exponent 14, right? Now you can see your first half-life and targeted value is not same. Okay. So you can perform another half-life. So we perform second half-life, divide the same value by 2. You will get 100. This is your second half-life.
Sir, how would we get 100?
100, oh sorry, 1 exponent 12 or 100 exponent, sorry, I just mentioned.
Sir, can you tell what's the formula again? It's a little confusing right now.
Okay, basically, formula is very simple. Whenever you got any type of values, so just consider initial value and find out the half-life of that value. Okay, basically in this question, We have another value that is actually targeted one, but we don't
Sir,
know about that value. Hmm?
I don't understand it.
Okay. In this question, we have initial value, right? We have initial value that 4 exponent 14 atoms. So this is the initial number of atoms in the sample. Okay. And next, it is mentioned after 22,000 years. Okay. So we don't know that after 22,000 year, what happens. Either it will take half-life, two half-life, three half-life. We don't know about it. Okay. So this 22,000 is still unknown information, right? We don't know about it, that after 22,000 years, how many half-life will take after this much years, right? We don't know about it. In question, it is mentioned after 22,000 years, the atoms of this sample remains this value. So this is our targeted value. Basically, we need to focus or we need to find this value, right? By performing the calculation of half-life. Basically, whenever you got question from the half-life, so if you don't know about the values, that what we need to do in this question, what we need to find out in this question, so process is very simple. Consider initial value. Okay, just like we consider. So we consider initial value and try to perform half-life one by one until you get your targeted value. Okay, you will get this targeted value, but you need to perform half-life. Okay, so that's why in our question, you can see we consider initial value and perform first half-life. So after first half-life, we got one value. Okay, that is 2 exponent 14. And that value is not the same like targeted value. It means we need to perform one more half-life. So we perform one more half-life, but still we are not getting targeted value, right? So it means we need to perform one more half-life. Okay. So when we perform one more half-life, so you will get your targeted value, 5 exponent 13. Okay. After the solution of one question, you will get idea that why we are doing this and how to perform this to find out your answer. So in this question, how many half-life we perform to get targeted value? 3 half-life, right? You can see we perform first, second, third. And after third half-life, you can see you got targeted value that is given in the question. Okay, clear? Any confusion at this point?
No, sir.
Okay. So we got targeted value. So now we know about two quantities. We know about initial quantity and final quantity. Now one thing is question mark, which is years, 22,000 years, right? So now what to do for with this 22,000 years? So it is clearly mentioned that in 22,000 years, your initial sample is decreased to your targeted sample, right? Because initial value is greater and targeted value is smaller. So it takes 22,000 years. And how many half-life we perform in this time? 3 half-life. Okay. So if we divide this number, if we talk about time, so we know that we perform 3 half-life. So if we divide this number by 3, you will get your answer for first half-life. Yes, any question? अच्छा आप क्वेश्चन पूछ रहे हो तो आप क्वेश्चन पूछ लो, फिर हम इसे कंटिन्यू करते हैं.
No, sir, clear.
Okay.
Sir, am I audible?
Yes.
Okay. So I was asking that the over here in the question they're asking to determine the half life of the thorium. So
Mhm.
sir, they mean that how much like in how many years it has
Yes.
taken to get to
Decrease
the
half
targeted
value.
point.
Yes. Basically, they are asking about just like we perform first half life over here. So we just mention over here first half life. We are not sure about exact time duration that after how many years the value decreases to half. Okay, we only know that after first half life the mass decreased to this value, but we don't know about the time duration, that after how many years we got this value. So that is question mark actually. Okay, we only know one thing, that there is a total time of 22,000 years to decrease the initial value to targeted value. Okay, but when we perform half life one by one, when we perform half life, so we got total 3 half life, and after 3 half life we got this value 5 exponent 13. It means that in 22,000 years there are total 3 half lives. Okay, because we started from initial value, we reached to the targeted value according to the question, and when we reach the targeted value, so in reaching towards the targeted value we perform 3 half lives. Okay, and in question it is mentioned after 22,000 years we got this targeted value. Okay, so it means that when we perform 3 half life to reach the targeted value, so it is very much clear that we need to divide this time into 3 equal half lives. Okay,
It's disappeared.
yes. So when we divide 22,000 by 3, so we will got answer 7333. Okay, it means that,
Sorry, your voice disappeared in between, so I couldn't hear anything.
okay, basically in our question, the time duration is 22,000 years, right? And we divided by 3 because we perform 3 half lives. For example, if you got 4 half
Yeah,
lives.
that the initial value was this, and they
Yes.
also know that after 22,000 years they got this targeted value. So what's they do? They have to ask us.
Now, they are asking about the half life, like how much time it required to decrease to its half value. Like if we perform first half life, so how long it will take to perform first half life, right? We don't know about it before like this value. So this is very simple. It will be like first half life takes this much years to decrease to half. Okay. Then we have another half life. Okay. Then the third half life. So this 7333 is your answer. Okay. Because after every 7333 years, the initial value is going to be decreased into the half value. Okay. Then again in next 7333 year, you will get another half value. Then again in 7333 year, you will get next half value. And this cycle will continue. Okay.
Okay,
So
sir.
in,
So they actually want to just ask us
yeah,
that well, how much time does it take for each half time?
yes, for each half life.
Okay, like how many years does it take it to get to its half life?
Exactly. Because we are only writing first half life. We don't know about the time duration. Either it is 1 minute, 1 year, 1,000 year, whatever it is. We are just writing first half life. Then we write second half life. Then we write third half life. Okay. But we are not sure about the time duration. That what is the time? We are just writing the mass value after every half life because that is given. But time is unknown because first we need to check how many half-lives it perform to get the targeted value. Okay. You will get the same type of questions. when there is no graph, so you will get same type of question. Let's find another question. So then you try by yourself, so it will be easy for you. Okay, this is isotope. Okay.
Sir, I want to ask this, that if there is
Hmm.
an atom or an element that has no radiations,
Hmm.
so we'll what would that atom or that nuclei of the atom would be called if it has no radiations emitting?
Basically, if there is no radiation coming out from any nucleus, so that is the normal. It is not radioactive. Those are not harmful. Those are non-radioactive. Okay.
Okay, so we'll say that those, for example, hydrogen is
Hmm. Yes,
non-radioactive.
consider
Uh,
hydrogen. Hydrogen is non-radioactive, right?
Okay.
Sir,
Yes.
can you send this PDF on WhatsApp after the class?
Yes, I will share this PDF after the class. Okay. Okay. So we have another part of half-life. Question is, using the number of radon 222 atoms present initially and the number present after 7.6 days, calculate the half-life of radon. Basically, it is the third part of the question, so we need to check values from the previous part. Okay, this is a lengthy question. We need to solve complete question to get the value. Okay, this is graphical representation. Okay, in this question, the isotope plutonium decays by the emission of alpha particles. Sometimes they also miss half-life with the radioactive decay. So we have plutonium 239 decays by the emission of alpha particle to an isotope of uranium. So plutonium decays to uranium, the isotope of uranium. And half-life of decay is 2.4 exponent 4 years. So this is the time of half-life. So half-life is given. And also you got the equation, right? That equation is incomplete. So you need to complete this equation. So how to complete this equation? We know about alpha particle. So what is the mass number? What is the proton number for alpha particle?
Sir, I can't see your screen.
Now is it
Yeah,
clear?
now it's visible.
Okay.
Yeah, now it's visible.
Okay. So you need to complete this equation first. You can see there are blank space for U and alpha to write down the number of atoms and number of neutrons over there. If we talk about alpha, so alpha is equals to the helium atom, right? So we need to write 2 and 4. Okay. And from atomic number, we need to subtract 2. It means we will get 92 over here. And from 239, we need to subtract 4. So it will be equals to 235. Okay. So this is the scenario for the equation. Okay. Now the next
Sir,
part
can
is
you explain it again?
basically
Like,
when we talk about alpha decay, beta decay. So last time we also discussed about the decay equations. You will get decay equations over here, right? And equation is very simple to solve. It is mentioned that it emits alpha particle. Okay. So just you need to know about the basic of alpha particle. For alpha particle, we know alpha is equals to the helium element, right? So in helium element, we have two number of proton and four number of nucleons, right? So in subscript, we need to write two, and in superscript, we need to write four. Okay. So for alpha, first of all, we need to write two and four. And you can see there is addition sign. So when we balance the equation, so it means your right side must be equals to your left side. Okay. So if we consider the left side, so on left side we have number 94. So it means 94 number will be divided equally between U and alpha. Okay. So 2 is already shared by alpha. So rest of 92 will be taken by uranium. Okay. 92 plus 2, 94. Like this. Okay. In the same way, the mass number is 239. From 239, 4 is taken by alpha because we know about alpha. And rest of 235 is taken by uranium. So you can see the mass number and the atomic number will be equals to the product. Okay, so the reactant and product both are same and equation is balanced, right?
So, sir, I have a question.
Mm.
So, the alpha particle is always going to have like 4 and 2.
Yes, it will remains the same.
Sir? It can't be changed.
Yes, we studied in the properties that the alpha particle is equals to helium. It remains helium always. Okay.
Okay.
Yes.
Sir,
Hmm.
uh, it says to complete the equation. So,
Hmm.
decay means that it is getting rid of the alpha particles, right? Like
Yes.
the emission of the alpha particles. So, why are we adding it here?
Basically, alpha particle emit outs, and rest of the element is called uranium. So in output, you are getting two different elements, right? One alpha, second uranium, right? Initially, we have only plutonium. Initially, we have one element, plutonium, and it splits into two elements, alpha, uranium. So that's why there is addition sign between them. If you again combine them, so you will get plutonium again. Okay. So that's why there is a addition sign.
So, plutonium is a mixture of uranium and alpha particles.
Yes. So this equation tells you that if plutonium splits in radioactive decay, this is specific plutonium. So it will decay like this into two elements. Then this uranium will decay into further other elements, then other elements like this. This cycle will continue to go on.
Okay, sir, should we rejoin?
Just complete this question, then we will restart. Okay. So in
Okay.
the next part, we have the count rate measured due to a pure sample of plutonium is 6,400 counts per second. So this is the count rate measured for plutonium. Calculate the count rate after a period of this year has elapsed, right? Now, the previous part and this part, these parts are interconnected with each other. In the previous part, you observe half-life is given, right? The value of the half-life is 2.4 exponent 4. Okay. And initially, this is our initial value. So initial value is 6,400 counts per second. Now the question is, now this time we got targeted time, not targeted mass number. We got targeted time this in this question. So this is our main target to consider this value. So question is again, if you read the question, calculate the count rate after this much years, after passing this much air, what will be the count rate? Okay. So if you compare your half-life, okay, this is your half-life given in the question. So half-life is less than the targeted value, right? Because in half-life we have exponent 4. In targeted value we have exponent 5. It means we need to perform more than one half-life, okay? Because your half-life value is small as compared to the targeted value. For example, if we consider again initial value,
Sir, 2.4 by 10 power 4 is the
half-life,
expression of a half-life
yes,
time, and how much has passed, like how much years it takes to get the
half
isotope
of
or
its
the
initial value,
emission to get to a half-life.
yes.
What are we
So
supposed to find then?
we need to find out after this targeted time duration, what will be the number of count rates after this year, right? So we don't know about this exact year 1.2 exponent 5, that how long we will consider it will take to perform half-life to reach this specific value. So again, method is simple. You need to perform half-life to check your answer. Like when we perform first half-life, so in this question we got half-life value. So it will take 2 exponent 4 years, right? And after half life it will be equals to 3200. Okay, now if we perform an other half life, so if we perform another half life, so it will be equals to
1600.
1600. And what will be the time? Initially for the first half life we got time 2.4 exponent 4. Now we need to add the same time, okay, like 2.4 exponent 4 plus 2.4 exponent 4. So it is equals to 4.8 exponent 3. But it's still, sorry, 4. Now this value is not your targeted value, okay? Because our targeted value is 1.2. So it means we need to perform one half-life. So if we perform one more half-life, so it will be equals to 800. So this is third half-life. And what about the value of the time? We need to add again 2.4. So in the previous value, we need to add 2.4 exponent 4. So that is equals to 7.2 exponent 4. So we are not still getting that targeted value. It means we need to perform one more half-life, 400, right? So this is fourth half-life. So after fourth half-life, we need to add again the same value. Okay. 2.4 exponent 4. We are getting answer 9.6, right? It's still not the targeted value. It means we need to perform one more half-life. So this is fifth half-life. Okay. So one more time, we need to add the same value, 2.4 exponent 4. So now you are getting your targeted value. Okay. That is equals to 1.20 exponent 5.
Sir, if we subtract divide 200,
Hmm.
if we divide 200 by 2, we get the answer 100, right?
400 divided by 2, 200.
No, sir, 200 divided by 2.
Yes, basically that will be the sixth half-life, but that is not required. Okay, because we got our targeted value after fifth half-life. Okay.
How, sir? Like, um, just like
Kalishma, we
calculating the
we added 9.6 and 2.4, and then we
Yes.
got
1.2.
1.2 multiplied by 10 and exponent 5
Right.
if we add them together.
Yes.
what did we add?
Basically, initially we
9.6.
started from 6400 and 6400 decreased to 32, and this is your time duration. Then 32 decreases to 1600. We need to
Sir,
add same time. So in this way,
I,
yes, after 400, when we divide 400 by 2, we got 200, and we need to mention the time. So in 9.6 exponent 4, we need to add the half-life, and we got this value 1.2. And at
sir,
this
what do
value,
we add to find the half-life? Like, I'm confused in this part.
basically we need to add the same time of half-life because half-life is given. So after every half-life, you need to add the time of half-life in the previous value
Meaning, after dividing 200 by 2, we get 100. So we added 9.6 exponent 10 4
plus this
with
value.
100.
Half-life. 100 is the count rate. That is not the time. Time is given 2.4 exponent 4. This is the half-life. So we need to
So
add
we added